Hello, this is Dr. Jennifer Ripley, and this is the first in a series of presentations on Factorial ANOVA, so going beyond one way. So we're going to start with the two-way ANOVA, and the thing that you want to make sure that you're clear on is that in a two-way ANOVA, this is not just like two levels of an independent variable. This is actually two different independent variables predicting an outcome or dependent variable. So for instance, an example might be, what are the effects of drugs and psychological treatment on symptomology, right? So drugs would be one independent variable, and it might have multiple levels, like Prozac and Paxil and no drug, right? So that would be 3 levels of drug. And then psychological treatment is a totally different variable, and it's going to have its own levels too. Like we're going to give some people CBT, and we're going to give some people emotion-focused therapy, and some people no therapy at all, right? So that would actually be a 3x3 ANOVA, meaning the first independent variable has 3 levels, so 3 different types of drug treatment the person could get, right? So I said Prozac, Paxil, and nothing. And the second independent variable of psychological treatment also has 3 levels: CBT, emotion-focused therapy, or no treatment. So you have 3 levels on each of those. And of course, symptomology is your continuous dependent variable. All the numbers that you're going to be seeing are going to come into play here, so I want to make sure that you're clear about them. You're going to be getting an F ratio, just like you did in the one-way ANOVA, and the F ratio is still the between groups variability on the numerator and the within groups variability on the denominator. It's just a more complicated formula in the background because we now have many groups being compared. There's going to be degrees of freedom. We're going to get between groups degrees of freedom, as well as the error degrees of freedom, or like the total degrees of freedom. We're going to have the numbers of levels of the IV-1. That's going to give us the between groups independent variables. So for instance, in my example, I said there's 3 different levels of drugs, for instance. So the between groups degrees of freedom will be 2 for that one. And you would have the same thing actually also for the therapy one, because it also had 3 groups. So the degrees of freedom would be 2. The within groups on your SPSS output is called error, and it is the degrees of freedom for each group multiplied by the number of conditions, but you can just grab that off of your output for SPSS and not worry about that. Okay, when you have independent variables in Factorial, like a two-way ANOVA, remember that you can have 2 or more levels, and they're all categorical, of your independent variables. They could happen naturally. For instance, drugs would be naturally in groups, right? Like, that's going to be a group. You're either going to get this drug, that drug, or no drug. But you can also force things into categories. So you might, for instance, say, I'm going to force height into short people and tall people, and I'm going to decide what that number is, and I'm going to force everybody into groups. So it can do either way. So you might think about this example as a fun example. If you were to play chicken with your cars out in the parking lot with some classmates, and we were to measure how many times you were the chicken, all right, playing over and over and over again, let's say that we're going to compare, your gender and your height, right? So 2 different independent variables, and height we forced into categories, right? And then the DV is the number of times you swerved off to avoid the collision with your classmates. Then we could run that study. That could be a study. That would be a two-way, a 2x2 ANOVA. This would be another one, say maybe a little more meaningful one. Let's say we take everybody in the class and we give half of you a Mack truck to drive, right? And we give half of you a little bitty tiny Toyota Tercel to drive in this game of chicken. And then we measured ahead of time whether or not you are high or a low risk taker. And then what we see here, you can see, is like 4 different numbers, right? So this would say, like, okay, the people that are in the Mack truck who were high risk takers, they swerved off 5 times total, right? Total of 5 times. The people in the Toyota Tercel, who were high risk takers, they swerved off 18 times in our multiple, chicken game. I don't know how y'all lived this many times, but pretend we did. Low risk takers in a Mack truck, they swerved off 6 times on average, right? These are mean scores. And then the Toyota drivers who are low risk takers, their average swerve off was 33. So they are pretty much swerving off all the time if you're a low risk taker driving a little bitty Toyota when playing chicken. So this kind of gives you an idea that when you are working with even just a simple 2x2 ANOVA like this one, you're actually going to have 4 different boxes of mean scores essentially that are being compared in the background. And you're going to be comparing all of them with each other in some way. All right, so what's important is to not get confused. A two-way ANOVA would mean that you have 2 independent groups. Each independent variable, right, has its own number of levels. So 2A ANOVA, 2 independent variables. Each of those IVs has 2, 3, 4, 5, 10, whatever groups within them or levels. So for instance, if you use the example of gender by college education to see if it predicts income, let's say gender has 2 levels in this sample, that we don't have anybody who is has a variety of gender identities, but just male, female. And then education has 4 levels. Let's just say that we divided education into 4 levels or 4 groups. Then this would be a 2x4 ANOVA. So you should ask yourself, if I have a 3-way ANOVA, how many independent variables do I have? Right? I'm going to have 3 independent variables, maybe gender, education, and parents' education, or something like that, right? 3 different things, constructs that you're measuring. If you have a chance to do some small group work later, you might kind of work through what a 2x2 ANOVA looks like, what a 2x3 ANOVA looks like, what a 2x2x2 ANOVA looks like, so you can start to get familiar and feel like it's not too hard to understand this material. You can have 3-way, 4-way, 5-way, and more. Of course, 3-way is 3 independent variables, 4-way is 4 independent variables. You're also going to get all their interactions, and the more you get, the more difficult it is to interpret these complex interactions. So you'll very rarely see anything more than a 3-way ANOVA in an article. Once in a blue moon, maybe a 4-way one, but I challenge you to even try to find a 4-way ANOVA or MANOVA in an article.